Hello and welcome to the Unit 4 Section 5 video on isosceles triangles. So remember, an isosceles triangle has at least two congruent sides. The congruent sides are called the legs. Now, the vertex angle is the angle that is formed by the legs. The side opposite the vertex angle is called the base. Okay, and the base angles are the two angles that have the base as a side. So in this figure, angle 3 is the vertex angle, and angles 1 and 2 are your base angles. So now, let's talk about the isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. So in other words, since we have two sides that are congruent, the angles opposite these sides, so opposite AC, we have angle B. That's congruent to the other angle that's opposite the congruent side, so AB. The opposite angle is C. So angle B is congruent to angle C. The converse of the isosceles triangle theorem states that if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So here we're going the other way. Opposite of angle E, we have DF, and DF is going to be congruent to the other angle that's congruent, which is F. We have DE. Okay, so now that we have the isosceles triangle theorem and its converse stated, we can do an example. So example 1, find each angle measure. So we want to find the measure of angle C here. Well, we know that if angle C is x degrees, that angle B is also going to be x degrees. And now we have all three angles, and we know that the sum of the three angles of this triangle, measure of angle A plus measure of angle B plus measure of angle C, that's going to be 180 degrees. So we have 38 is angle A, we have x for angle B, we have x for angle C, and now we can solve. 38 plus 2x equals 180. Subtract 38 from each side, you get 2x equals 142. And divide each side by 2, and you get x is 71. So the measure of angle C, which is what we're looking for, which is just x, is 71 degrees. For B, we're looking for the measure of angle S. So here we know that angle S and angle R are congruent. So therefore, the measure of angle R is equal to the measure of angle S. Measure of angle R is x plus 30. The measure of angle S is 2x. Subtract x from each side, and you get that x equals 30. But we need to find what the measure of angle S is. So we know the measure of angle S is 2x, which is 2 times 30. So the measure of angle S is 60 degrees. Now let's talk about a special type of isosceles triangle. An isosceles triangle's base angles equal the vertex angle is called an equilateral triangle. Now you may recall us talking about equilateral triangles. For an isosceles triangle, you just have to have two sides the same. An equilateral triangle has two sides the same, but it also has that third side happening to be the same. So therefore, all equilateral triangles are also isosceles. However, you cannot say that an isosceles triangle is equilateral. Okay? So, the equilateral triangle corollary. A corollary is just something that comes off of an established theorem. So this corollary is a result of the isosceles triangle theorem, and it states that if a triangle is equilateral, then it is also equiangular. The equiangular triangle corollary says if a triangle is equiangular, then it is also equilateral. So in this first one, since we have all the sides the same, then we can say that all the angles are the same. Angle A is congruent to angle B, which is congruent to angle C. In this one, since D, E, and F, all those angles are the same, then we can say that DE is congruent to DF, which is also congruent to EF. So, knowing that all the sides are the same and all the angles are the same, and more specifically, we happen to know in an equilateral triangle, all the angles measure 60 degrees, because if all three are the same, 180 divided by 3 is 60. So, in example 2a here, if I'm given that angle C is 3x plus 15, we know that all three angles of an equilateral triangle are 60 degrees each. So I can just set 3x plus 15 equal to 60 degrees, and then just solve for x from there. Subtract 15 from each side, and divide by 3, and you end up with x equals 15. Now for B, we know all the sides are the same. So if I have the side of DF and the measure of EF, I can just set those two equal to each other. 4t minus 8 is going to equal 2t plus 1. So here, I'm going to subtract 2t from each side, so I'm going to get 2t on this side. I'm going to add 8 to each side, which gives me 9 here. And so t is going to be 9/2. All right, that finishes off this relatively short section on isosceles and equilateral triangles. Coming up in the next section, we're going to finish off the unit talking about bisectors and medians.